Another trade-off is memory versus latency. And the best example of this is a cache. If you get a request in any system, the fetching from a database, it's going to take time, let's say 100 milliseconds. If you have the popular profiles, the people who are extremely active on Instagram, all cached in an in-memory cache on the server, which means Gaurav, he uses Instagram a lot. He's a super active Instagram user. What will happen is Gaurav keeps asking for his profile. He keeps checking, what's my stats? How many followers do I have now? Keep his profile in the cache, keep his follower count in the cache. And whenever he asks for an update, check whether there's any update in the cache and return a response. Instead of 100 milliseconds, maybe you can do this in 10 milliseconds. So for the super active users or for the super hot data, you want to keep it in memory in a cache. You're seeing that if you want to reduce latency from 100 milliseconds to 10 milliseconds or from X to Y, where Y is lesser, you get lower latency, but you need more memory. Instead of having one copy of Gaurav's profile here in the database, you now need to store it in a cache also. I'm spending money for the cache, I'm using memory to get low latency. If I want to use lesser memory, if I want to keep my cache size small, I may have to increase the latency of the responses. More and more of my responses will take 100 milliseconds. Can you take a medium approach? Yes, the medium approach is basically keep hot entries in the cache, use a good replacement algorithm, use a good write policy. We have all of this in the consistency chapter, so you might want to go through that. If you have any doubts on this, of course, leave them in the discussion right here, or you can always come in the end.